Okay, so we're going to look at an example of an elastic collision problem. This is from a past AP exam. It's a great idea of like what kind of questions are going to be coming at you. So we have in this problem a perfectly one-dimensional problem where we have an object of mass m going at speed v naught, and it's going towards an object that's more massive, a 3m mass, but its initial velocity is at rest. So it wants to know what are the velocities of these objects following the collision. So first thing to realize is this is a perfectly elastic collision. Nope, that's a lie. The first thing to realize is that this is a collision. In any collision, as long as there are no outside forces, and this doesn't discuss any outside forces, the momentum has to be conserved. So we want to check first and foremost to see what our momentum is at the beginning. At the beginning, this object is not moving, so it has no momentum. That means that our initial momentum is just going to be m times v naught. But I don't know why in my head that seemed like it was going to take longer. All right, there we go. The momentum is m times v, which in this case is m times v naught. There, now I made it take longer for no reason. So let's look at our options and eliminate things that aren't actually a total momentum of m v naught. This one right here, the mass m is 0 and object 3m. Okay, well, its mass is 3m. The velocity is 3v naught. So the total momentum here would be 3m times v naught over 3, which equals mv naught. So this one gets a pass. It did conserve momentum. Looks good. Our next problem, this one here, we have a total of v naught over 4 for this object. And then this object here would be 3m times v naught over 2. So that would be a total of v naught over 4, or sorry, m v naught over 4, my mistake, m v naught over 4 plus 3m v naught over 2, which would be 6. This works out to be 7 m v naught over 4, which is not right. This one does not work. It doesn't have the right momentum at the end that it should have had at the beginning. Our next one, v naught over 2 plus x and v naught over 2 also plus x. This one here, for this part here, would be m v naught over 2. And for the other mass, it would be 3m v naught over 2. So if I add those together, that's v naught over, or m v naught over 2 plus 3m v naught over 2. That's 4m v naught over 2, which is equal to, did I do my math right? I think I did. Yeah, that's equal to, yeah, okay. Why am I brain farting right now? Yeah, that's equal to 2m v naught. So that one also doesn't work because that one has more momentum at the end than it did at the beginning. All right, our very last option. This one here, unfortunately, I have a little bit more space below it, so I'll do it there. This is m times v naught over 2. This one here is 3m times v naught over 2. If I add those, but this one's negative. Remember that it's negative there. So that would be 3m v naught over 2 minus m v naught over 2. This one actually comes out to be, well, it's 2 over 2 m v naught, but that's the same thing as m v naught. So this one also passed muster. Actually, that one also works because we've conserved energy. So it has to be A and D, or A or D. Now from here, there's some more work, but we at least got it down to a 50% chance right there. And that honestly should have been a lot faster if I didn't like get confused somewhere around here. And you don't even have to carry these equations all the way through. As soon as you notice that the number's not going to be the same, you can just move on. So I did know that B was just like absolutely not going to work halfway through. For some reason, C I thought was going to work, and that's why I was confused when it didn't. So sometimes I'm bad at math. So our options are A or D. Now we look at the fact that this is an elastic collision. Elastic means the kinetic energy has to be conserved. So now we have to look at how much kinetic energy did we start with. I'm going to erase everything except for the fact that we got rid of some of our options. I do need some more space on my little template here. So now let's look at kinetic energy. The initial kinetic energy, remember that kinetic energy is 1/2 mv squared, and this problem here would be 1/2 m times v naught squared, or 1/2 m v naught squared. That means we have to have the same amount of energy at the beginning as we do at the end. So let's check A. All right, obviously here, we're going to have 0 kinetic energy for mass A. For mass B, it's going to be 1/2 times the mass of 3m times the velocity v naught over 3 squared. When I evaluate that, that ends up being 3m over 2 times, let's see, v naught squared over 9. All right, I can simplify that a little bit, and it turns into something like v naught squared over 6. I'm sorry, mv naught squared over 6. That's not what we said it was going to be. We said it needed to be 1/2 mv naught squared. So since these are not equal, A has to be wrong. D is correct. I'm not going to make this video any longer by proving it, but I do recommend that you try and prove it to yourself, so that you can see the fact that, that this checks out. So D was the right answer here. But honestly, like if it was me doing the AP exam, I ruled out B and C using momentum. I ruled out A using energy. Unless I have oodles of time left at the end of the exam, I'm picking D now and moving on. I'm not going to take the time to prove it unless I have tons of time. So now that we've done that problem, I have a very, very similar problem for you guys to look at. In this problem, we have a block of mass m, no friction. It's hitting the pendulum E thing, and I want to know what are the speed and direction of the blocks right after the collision. That short time after means right after the collision. So I want you guys to work and figure that out. And if you think you know the answer, please share it in the comments. I'm getting better at being a YouTuber. I'm trying to get you guys to start commenting. Pretty soon, I'm gonna start every video with like the like and subscribe thing. See, I'm not ready for it yet, but I'm not quite there yet in my multi-million-dollar media YouTube influencer agenda. That's like my secret plan here. So anyways, try and do this problem right here. Share it in the comments, justify it, share what you did, and hopefully we can get a good conversation and give you guys the chance to practice these problems a little bit. All right, thank you guys for watching. Have a great night.